welcome to the next session of finite element analysis. In this session, I am going to solve question 6 of weighted residue approach. Solve the following differential equation using Galerkin method. Compare the answers with exact solution at x is 3.5, 4, 4.5 and 5. So these are the 4 points at which I am going to check the answers for Galerkin method and compare the same with exact solution. This is a differential equation given to me, and the domain is something very different which we have not used till now, that is from 3 to 5. The boundary conditions are given. I'll start. Now, before assuming the approximate solution in this question, I need to first sort out this differential equation in a form which is understandable to me. For that, I'll start with the given equation. Now this is derivative of two terms which are in multiplication, which means derivative of u into v. So this formula can be applied here. So I'll write down u derivative of this term. So this will become d square u by dx square with a negative sign, and then I'll have, it was u derivative of v, and then it will be v into derivative of u is equal to x square. Therefore, this becomes d square u by dx square minus du by dx, and derivative of x minus 1 with respect to x will be only 1. So this x square coming on this side, making it 0. So I can just remove all the negative sign. Therefore, I get x minus 1 d square u by dx square plus du by dx plus x square is equal to 0. Now this is something which was given to me. This is my first equation which I am going to use as a differential equation for this question. Now I'll start with assuming of approximate solution like in the previous 5 numericals I have done. Let the approximate solution be u is equal to c0 plus c1x plus c2x square plus c3x cube. I mark this as equation 2. Now you know how I have got up to the term 3. I am going to apply some boundary conditions. First boundary condition is at x is equal to 5, u is equal to 10. When I substitute here, I will get therefore 10 is equal to c0 plus 5c1 plus 25c2 plus 125c3. Therefore, I can say c0 is 10 minus 5c1 minus 25c2 minus 125c3. This is my one value of the constant that I want to find. Now I have to use the second boundary condition, that is at x is equal to 3, my u dash is equal to 5. In that case, I cannot use the equation of u directly, I need to find its derivative. So u dash will be c1 plus 2xc2 plus 3x square c3. Here I will substitute 5 is equal to c1 plus 6c2 plus 27c3. Therefore, I get c1 is equal to 5 minus 6c2 minus 27c3. I will substitute the value of c0 and c1 in the equation of u. Therefore, I will get u is equal to, for c0 I will write down 10 minus 5c1 minus 25c2 minus 125c3. Next I will have plus 5 minus 6c2 minus 27c3 into x plus c2x square plus c3x cube. This will be as it is. I'll open this bracket, so I get 5x minus 6x c2 minus 27x c3 plus c2x square plus c3x cube. Here instead of c1, I again have to write the equation which I have obtained for c1. So I get 10 minus 5, 5 minus 6 C2 plus 27 C3 minus 25 C2 minus 125 C3 plus 5x minus 6x C2 minus 27x C3 plus C2 x square plus C3 x cube. This will be 25 minus, and minus makes it plus 30 C2 plus 135 C3 minus 25 C2 minus 125 C3 plus 5x minus 6x C2 minus 27x C3 plus C2 x square plus C3 x cube. Now first I'll take C2 terms, so I get 30 minus 25, then I have minus 6x plus x square. These are the terms of C2. Next I'll write for C3, so I'll have 135 minus 125 minus 27x plus x cube. So all my C2 and C3 terms are done. So I am left with plus 10 minus 25 plus 5x. So now if I write the 5x minus 15 term at the start, here I get C2. This is 5 minus 6x plus x square plus C3 10 minus 27x plus x cube. This is my equation of u. I mark this as equation 3. Next I'll write down, since solution is an approximate one, therefore x minus 1 d square u by dx square plus du by dx plus x square will not be equal to 0. It will be equal to r, which is residue. This is equation number 4. I'll be calculating these terms by using the equation of u. Therefore, I have du by dx as 5 plus C2. Here I'll have minus 6 plus 2x plus C3 minus 27 plus 3x square. When I calculate d square u by dx square, this will be 2C2 plus 6x C3. When I substitute in the equation of r, therefore r is equal to x minus 1 into 2C2 plus 6x C3 plus this entire term here. If I take the C2 and C3 terms together, apart from that I have x square plus 5 from here, and if I take C2 terms common, I get 2x minus 2 from here, then I get minus 6 plus 2x, and for C3 I'll have 6x square minus 6x minus 27 plus 3x square. When I solve this, I'll get 4x minus 8, and for C3 I'll get 9x square minus 6x plus 27. This is the equation of r. I mark this as equation 5. Next is weighted integral form. This equation is very important to note because for the first time for weighted integral form, I am going to write from 3 to 5. Very important. Till now I have always used 0 to 1 because that was the domain of x. In this question the domain is from 3 to 5. So I'll have wi r dx is equal to 0. Therefore from 3 to 5 wi, this is the equation of r, x square plus 5 plus c2 4x minus 8 plus c3 9x square minus 6x minus 27 dx is equal to 0. This is my equation number 6. I will be using various weight functions to calculate the value using different methods. In this question, I have been asked to calculate for Galeckian method specifically. When I solve this question by Galeckian method, for I is equal to 1, wi will be W1, which will be coefficient of C2 in U, which is 5 minus 6x plus x square. This is what I had found. So when I substitute in this equation, I get integration 3 to 5 minus 6x plus x square and this entire term. When I solve this equation, I get 37.33 C2 plus 422.4 C3 is equal to minus 102.933. I mark this as equation A. For I is equal to 2, Wi will be W2, which is coefficient of C3 in U, which was 10 minus 27x plus x cube. So therefore, integration 3 to 5 and the entire term of bracket, I get 422.4 C2 plus 4790.4 C3 is equal to minus 1162.7. This is my equation B. Solving equations A and B, I get C2 as minus 4.87 and C3 as 0.186. I'll substitute these two in the equation of U. Therefore, I get U is equal to, now here if I substitute U as 3.5, I get the answer as 30. U at 4 as 13.286 and U at 4.5 as 12.2. Now I need not find U at 5 because that is something which is a boundary condition and is already given to me, but still you can substitute and check if your answers are correct. Next I'll go to exact method. Now the differential equation is minus d by dx x minus 1 du by dx is equal to x square. Now first I will start with integrating both sides. When I integrate both sides, this derivative sign will not remain. So what remains is only this much portion, x minus 1 into du by dx, and here I will get minus, okay, this term minus I am shifting here. So this becomes integration of x square and dx. So when I integrate this, I'll have minus x cube upon 3 plus c1. c1 is the constant of integration, first constant of integration, and here I have x minus 1 du by dx term. Now I need to find the value of c1. For that, I'll just shift this term over here. It becomes x cube upon 3 into x minus 1 plus c1 upon x minus 1. I will apply a boundary condition that u dash at 3 is 5. This is a boundary condition given to me, which means at x is equal to 3, when I substitute x is 3 here, my du by dx value is 5. So therefore, if I write 5 is equal to minus 3 cube upon 3 into 3 minus 1 plus c1 upon 3 minus 1. When I solve this, I'll get the value of c1 as 19. Therefore, this equation becomes du by dx is equal to minus x cube upon 3 into x minus 1 plus 19 upon x minus 1. Now I need to integrate again to find the equation of u. So I'll integrate once again. When I integrate again, this side will become integration of du is equal to, here I'll have minus 1 by 3 integration of x cube upon x minus 1 plus dx, 19 integration of 1 upon x minus 1 dx. So this is what I need to integrate. If you're well versed with integration, you would know that this is integration of a plus integration of b. Now this is integration by parts, and apart from that, this term x cube can also be sorted like this. This is integration of x cube minus 1 plus 1 upon x minus 1 into dx. Now what I am doing is, I am just adding and subtracting 1 from here. I'll show you why. This can now be segregated and written as x cube minus 1 upon x minus 1 into dx plus integration of 1 upon x minus 1 dx. I just segregated these terms. The reason was, when I have this integration over here, this is x cube minus 1, that is a cube minus b cube. This can be separated as, I'll just complete this. This has a formula. Okay, I'll just write in bracket here, minus 1 by 3. This has a formula x minus 1 into x square plus ax plus 1. This is a formula upon x minus 1 term here into dx plus 1 upon x minus 1 integration, and lastly I have 19 integration of 1 upon x minus 1. Here these two terms will get cancelled out. So what remains is integration of this much portion. So 1 upon 3 is common, and I have integration of x square plus x plus 1 into dx plus integration of 1 upon x minus 1 dx plus 19 integration of 1 upon x minus 1. When I solve this, I'll have x cube upon 3 plus x square upon 2 plus x, that is integration of these terms individually. Now integration of 1 upon x is log mod x. Similarly over here it is 19 log of x minus 1. Now since I have integrated all the terms, I should also add constant of integration c2. I'll just multiply this 3 inside, so I get minus x cube upon 9 minus x square upon 6 and minus x upon 3. Here I have minus 1 by 3 log of x minus 1 plus 19 log of x minus 1 plus c2. This is my equation of u. Now I want to find the value of the c2. For that I am going to apply the second boundary condition which is left. So applying boundary condition, that is, at x is equal to 5, my u is equal to 10. When I substitute over here, I get therefore 10 is equal to minus 5 cube upon 9 minus 5 square upon 6 minus 5 upon 3, 1 upon 3 log of 4 plus 19 log of 4 plus c2. When I solve this, I get the value of c2 as 3.82. And now I'll substitute this over here in this equation. Therefore, I'll get u is equal to minus x cube upon 9 minus x square upon 6 minus x by 3, 1 by 3 log of x minus 1 plus 9. If you want, you can solve these two terms also, because they have log of x minus 1 common, and here I'll have plus 3.82. Therefore, if I have to find u at 3.5 now, I'll get the value as 12.95. U at 4 I'll get as 13.21, and u at 4.5 I'll get as 12.2. So this is how the numerical is supposed to be solved. Now I would like to add one small thing over here, that is, if this question would have been asked using subdomain method. Now here it is Galerkin, so you had no problem. The domain was directly 3 to 5. I just want to add one small thing, that suppose if there is subdomain method asked over here, for I is equal to 1, my wi will be w1, which is 1. The domain for I is equal to 1 will be 3 to 4. This is something which you can just make a note of. For I is equal to 2, my w2 is 1 again, and the domain will be 4 to 5. This is how the domain is supposed to be divided. 3 to 4, 4 to 5. Previously I was always saying half. So half of 1 was 0.5. So you never had to think much. So you just wrote 0 to 0.5 and 0.5 to 1. But when you look here, it is 3 to 5. I can't divide this domain into half and make it something other number. Half means you just divide such that difference is going to be the same, like 3 to 4 and 4 to 5. So with this I end the session. I hope you have understood the numerical. You can try this numerical using subdomain method. You will get approximate answers. In the next session we will see one last numerical on this chapter. See you in the next session. Thank you.